I tried shrinking the file and it was still too big, so I'm trying to figure out other ways to be able to mail out the recording. So hopefully the lab here can help me with that. All right, so let's do one more quick example right up underneath this. So if we wanted to graph f of x equals negative absolute value of x. Okay, so you already know you're going to remove the negative 1 because you want the parent function. Absolute value of x is your parent function. Oops, move it up. Your x and you have your y, and this is how your absolute value of x will look. F of x equals absolute value of x. Okay, so once that negative appears in front of it, so negative f of x equals negative absolute value of x. So that means I'll move that up a little bit since I'll need a little more room at the bottom. You have your x and you have your y. And this is our f of x equals absolute value of x. Then if we just flip it over the x-axis, then that's our f of x equals negative absolute value of x. So the reflection or the reflective property is pretty straightforward. You're just going to flip it. Now if the negative's on the inside, then we're going to flip it across the y-axis. And we'll do a couple of examples of that one. All right. Okay, so let's say, for example here, you wanted to graph f of x equals the square root of negative x. Okay, so the negative is not on the outside like it was before. Right now it's on the inside of the square root. Okay, so just like before, f of x equals square root of negative x is the same as saying f of x equals the square root of negative 1 times x, where you're going to get rid of any numbers that aren't exponents. So your f of x equals square root of x is your parent function. Okay, so that's where everything's going to start from. Okay, so you have your x and you have your y. And this is our parent function of square root of x. Okay. Now if the negative was on the outside, it would just flip over the x-axis. But since the negative is on the inside, it's going to flip over the y-axis. Here we have x, and here we have y, and we'll give a dotted outline. So that's f of x equals square root of x. So since it's on the inside, we flip it across the y-axis. So this would be our f of x equals square root of negative x. Okay. So really, if you look at this and say if I'm going to graph f of x, I just plug in x values and get y values. So when it's negative, here you're plugging in negative x values and getting y values. Okay. So, but in reality, you would end up with a complex graph because you have a negative square root, but we're not going to get into all that. At least not yet. We will later. All right. So any questions on this one? All right. So let's do another one. Actually, with x squared and absolute value of x, if you flip it across the x-axis, you end up with the exact same graph. So let's say, for example, if you wanted to graph f of x equals absolute value of negative x. Okay, so we know if you got rid of that negative 1, f of x equals absolute value of x is your parent function. Okay, so if we graph that, you have your x and you have your y, and your absolute value of x is nice and neat and looks like that. Okay. Now if we get a v and we flip it around, it's still just a v. So it's the same thing with a u. That kind of looks like the x squared. If we get a u and just flip it around, it looks the exact same way. So that's why if you flip that one across the y-axis, x and y, just flip it, it looks the exact same way. So you really can't have the dotted outline because you get the exact same graph. Okay, so you kind of think of it as flipping a v. Flipping f of x equals x squared and f of x equals absolute value of x across the y-axis gives the exact same graph. Okay. So if you do happen to see one where it says graph f of x equals negative x and that whole thing squared, then you know it's just going to be the exact same thing. Now if it was negative absolute value of x, you saw before it flipped across the x-axis when the negative's on the outside. All right. So any questions on that one? All right, I'll leave that one up for a few more seconds. Everyone looks done. Okay, so let's say if we have a graph of, let's say f of x equals x plus 3 squared minus 2. So we know whenever that plus or minus is on the outside, it's going to shift up and down. Whenever that plus or minus is on the inside, which you have the plus 3 on the inside of the x squared, you know it's going to shift left to right. Okay, so just a quick little breakdown. So for f of x equals x plus 3 squared minus 2, you know this minus 2 means it's going to shift down 2 units. And because this is on the inside, and remember, when it's on the inside, that plus means it's going to shift to the left. Bless you. That minus would mean it would shift to the right. So this is going to shift 3 units left. Okay. So now all we have to do is find our parent function. Okay, so if you have f of x equals x plus 3 squared minus 2, you're going to get rid of all the numbers that aren't exponents. So you're going to remove those two. Which means you're going to have f of x equals, that disappears, so it's just x squared as your parent function. Okay, so we're going to start off with that parent function. We have our x, and we have our y right there. Okay, so we're going to start off with our x squared. Okay, so this is our f of x equals x squared. Now, it doesn't matter which one you do first. You can do the left to right first, the up and down first. Doesn't matter at all. Always try to get the left and right out of the way. Just my personal preference. But if you want to shift that down 2 and then left, and that would work too. Okay, so we have our x and we have our y. And we're going to give an outline of our x squared. Oops, should have made that a little further that way. Give that a little more room. There we go. Okay, so this is, let's say, -1, -2, -3. So this is our f of x equals x squared. We're just going to get that whole thing and shift it here. So this is our f of x equals x plus 3 squared. Okay. So all we did was just take it and just worry about one part of it. Okay, so now we're going to go to the next one, and we're going to pick up right where we left off here. Okay, so we picked up at f of x equals x plus 3 squared. Okay, so now we're going to get that and shift it 2 units down. Okay, so we're going to get this entire, oh, should have wrote that and dotted, sorry about that. But this f of x equals x plus 3 squared, you're going to get that x plus 3 squared minus 2. All right, forgot to draw that as a dotted line. But move that up a little bit. But does that make sense? All right. All right. Any questions on this one? Okay. So we'll do one more example. I'll make sure everyone's. Okay. Okay, so let's say, for example, if you wanted to graph f of x equals negative x minus 1 squared, let's say, plus 1. So just a breakdown of everything that's going on there. So f of x equals negative x minus 1 squared plus 1. This 1 on the outside means it's going to shift up 1 unit. Now whenever you have the number on the inside, remember the minus on the inside means it's going to shift right. If that would have been a plus, it would have shifted left. So that minus 1 is going to shift 1 unit right. Okay. And that negative on the outside, remember that negative means reflective. So if it's reflective, and since it's on the outside, it's going to reflect across the x-axis. Okay, so everything there has kind of a job, their own job, every number. Okay, so the first thing we need is our parent function. So we have f of x equals negative x minus 1 squared plus 1. You'll want to remove that, remove that negative 1. So you're going to remove everything that's not, every number that's not an exponent. So f of x equals x squared is your parent function. Okay, so that's where everything's going to start. Okay, so we have an x and we have a y, and we know that our x squared looks something like that. Okay, so we have our f of x equals x squared. Okay. Once again, if you wanted to, you could do the reflection first, you can do the shift up first. It doesn't matter at all. Okay, so let's say if we have our, I'll stay on my normal path and do the inside number first. Okay, so we have our x and we have our y, and we know that our x squared looks something like that. I should have wrote that on the other side since I'm shifting that to the right. Okay, so since we're shifting that to the right 1 unit, let's say this is our 1 here, and that whole graph just shifts that way. So this is our f of x equals x minus 1 squared. All right, so you got part of it out the way. Okay, so we're going to continue right where we left off. Remember to dot. Okay, so remember this is your f of x equals x minus 1 squared. So if we're going to add 1, it's going to shift up 1 unit. So this is our 1 here. This whole graph is going to shift. Probably should have made that a little lower. Best invention since sliced bread, I'll tell you. F of x equals x minus 1 squared. There we go. So we're going to shift this whole graph up 1. So f of x equals x minus 1 squared plus 1. Okay. So the only thing left is that reflection, that flip across the x-axis. Okay, so we're going to pick right up where we left off. And we're going to have our x and y axis. And that's at 1. And that ended about right here, give or take. Uh-oh. Okay, so remember this is our f of x equals, I should have given that a little more room. F of x equals x minus 1 squared plus 1. Okay. So since you have that negative in front, it just flips, but not across the x-axis. Because this is where the bottom is, it's just going to flip right across that. Okay, so this would be your f of x equals negative x minus 1 squared plus 1. Okay, so when it's all said and done, all of the shifting here and shifting there and shifting up and shifting down, this is what your absolute last graph would look like. All right, straighten that up. All right, so any questions on that one? All right, I'll leave that up. Let everyone finish drawing that one out. All right. Okay, so now we're going to look at non-rigid transformations. Okay. Now, up till now, all of our graphs have been the exact same shape. We either shifted it left, shifted it right, up, down, we flipped it, but it never changed its actual shape. So with these, we're going to change the actual shape of it. All Alright, so let's say if you have let's say a y equals some f of x, and c, didn't really need that, is a real number. One, if c is bigger than 1, then f of x is stretched vertically when y equals c times f of x. And I'll give you examples of what I mean by stretched vertically and shrinking vertically. Now, if c is less than 1, so if you have a fraction or a decimal number less than 1, then f of x shrinks vertically when y equals c of f of x. Alright, so let's say, for example, you wanted to graph say f of x equals 3 times absolute value of x. Okay, where in this case, of course, c is greater than 1. Okay, so remember f of x is equal to 3 times absolute value of x. You're going to remove anything that's not an exponent. That gives you f of x equals absolute value of x as your parent function. Oh, move that up a little bit. Here we go. All right, so we're going to draw our f of x equals absolute value of x. Okay. Now we know in this case c is equal to 3 and is greater than 1. So c is greater than 1. So if we were to graph that, we have our x and we have our y. Okay, and we have our f of x equals absolute value of x. And what it means by stretched vertically is that will now, everything, when you plug in absolute value of 1, your answer was 1. Here, if you plug in absolute value, x equals 1, instead of your answer being 1, it will now be 3. So if you plug in 2, absolute value of 2 was 2. Now if you multiply that by 3, you end up with 6. So now this entire graph stretches upward. Okay, so this would be your f of x equals 3, absolute value of x. Does that make